When dealing with noise issues in 480 volts motor systems, particularly those involving variable frequency drives or VFD, several strategies can be employed to mitigate noise pickup, especially on moving metal parts. These solutions focus on providing low impedance paths for high frequency noise and understanding the scientific principles behind noise reduction. Firstly, consider conductive grounding brushes. These brushes make direct contact with the moving parts, establishing a continuous, low-impedance path to ground. This is critical for dissipating high-frequency noise that would otherwise accumulate on the moving components. Secondly, explore EMI shielding. Enclosing the moving parts within a metal enclosure or applying EMI shielding paint can significantly reduce noise coupling. The metal acts as a barrier, preventing electromagnetic interference from reaching the sensitive components. Thirdly, install ferrites. Ferrite beads or clamps can be placed on the cables connected to the moving parts. Ferrites attenuate high-frequency noise by increasing impedance at those frequencies, effectively blocking the noise from propagating along the cables. Fourthly, consider plasma spray coating. Applying a conductive plasma spray coating to the moving parts creates a low impedance path to ground, similar to grounding brushes but as a more permanent and integrated solution. Fifthly, use capacitive coupling. Integrating capacitors between the moving parts and ground can reduce noise. Capacitors provide a high impedance path for low frequencies, blocking them, and a low impedance path for high frequencies, shunting them to ground. From a scientific perspective, noise is fundamentally caused by electromagnetic interference, or EMI. Electromagnetic fields couple with conductors or other conductive materials, inducing unwanted currents and voltages. To effectively reduce noise, impedance matching is crucial. The noise source and the receiving element should have similar impedances. This minimizes reflections and maximizes power transfer, allowing the noise to be effectively shunted to ground. Providing a low impedance path is essential. A low impedance path allows noise to return to its source, reducing its amplitude and preventing it from affecting other components. Capacitance and inductance play a key role in noise reduction. Capacitors reduce noise at low frequencies by presenting a high impedance path, while inductors reduce noise at high frequencies by providing a low impedance path. Shielding, using metal enclosures or shielding materials, blocks electromagnetic fields by either reflecting or absorbing them. This prevents the fields from coupling with susceptible components and causing noise. Additional tips include: firstly, using stranded wire with a large cross-sectional area. This minimizes inductance, which is beneficial for reducing high-frequency noise. Secondly, avoid sharp bends in cables. Sharp bends can create impedance discontinuities, leading to reflections and increased noise. Thirdly, keep cables away from sources of EMI. Transformers, motors, and other electrical equipment can generate significant electromagnetic interference. Fourthly, consider using a line filter. A line filter at the input of the motor system can attenuate noise before it enters the system. Fifthly, ground all metal components of the system. This provides a common reference point and helps to minimize noise caused by ground loops. When selecting components and implementing these solutions, always adhere to relevant electrical codes and safety standards, such as those outlined in the National Electrical Code or NEC. Ensure that all grounding and bonding connections are properly made and that the system is safe to operate. Always prioritize safety when working with electrical systems. Before beginning any work, to energize the circuit and verify that it is safe to proceed. Use appropriate personal protective equipment or PPE, such as safety glasses and gloves. If you are not qualified to work on electrical systems, consult a qualified electrician. The specific solutions that are most effective for mitigating noise will depend on the particular characteristics of the motor system and the nature of the noise being generated. A systematic approach to troubleshooting and experimentation may be necessary to identify the optimal combination of techniques. Noise reduction in motor systems is a complex topic, but by understanding the underlying principles and applying appropriate solutions, it is possible to significantly reduce noise pickup and improve the performance and reliability of the system. These solutions, which included conductive grounding brushes, EMI shielding, ferrites, plasma spray coating, and capacitive coupling help create a low impedance path, which is crucial for minimizing the effects of EMI and ensuring that high-frequency noise is effectively managed within the motor system. Remember that continuous monitoring and maintenance are key to ensuring that the noise reduction strategies remain effective over time. Regular inspections of grounding connections, shielding integrity, and filter performance can help identify potential issues before they lead to significant noise problems. Also, understanding the scientific basis for noise reduction strategies such as impedance matching and the roles of capacitance and inductance is essential for developing effective solutions. By grounding all metal components, using stranded wire with a large cross-sectional area, avoiding sharp bends in cables, and keeping cables away from sources of EMI, one can further minimize noise. Line filters are also important in reducing noise at the input of the motor system.